Hello coders, welcome to Coding Every Day. My name is Otto and this is another episode of the Asta Manager project. For those of you that don't know what the Asta Manager project is a project where episode by episode we go through all the steps that we need to build something great, but not just building it and having it working locally, but I will show you how you can add unit tests, integration tests, browser tests, how you can add deploying pipeline, how you can host it in the cloud, and essentially everything you need to know from 0 lines of code to having it in production. So hopefully this will help you build your own project, something that you are passionate about, but you never got the chance to get it live because maybe you have the code, but you don't know how to get through all the other steps that you need to have something actually working online for people to use. Okay, so in the last episode, we had a look how we can have an in-memory version of our databases that we can use for testing purposes. And in fact, we did build some tests and we added dependency injection. So even during our test, we use dependency injection um, to create our repositories. And this shows the power of abstracting everything from the domain. Um, and in this episode we are going to do the same, but this time implementing the repositories using Cosmos DB. So let's get started. Let's open Visual Studio, and this is exactly where we left. I'm going to collapse that, and the next thing we need is to create a new project. Again, just class library, we call it like that, Asta Data Cosmos DB, .NET 5, I'm happy with that. And as usual, we delete that class, we don't need that. We don't need that. What we need though, we need some dependencies. So the first thing that we definitely need is a dependency on Cosmos DB. So let's add that. So we go to manage NuGet packages, we browse, search for Microsoft Azure Cosmos. This is the NuGet package that you will need, and you install that. It will come with a bunch of other things that you will probably need, which is fine. You read all these licenses, and you accept. Fine, so when you install the package, it will come with this little notice, and I think that's fine. No, I have no issues there. So the other thing that we need, and is similar to what we needed for the in-memory, we need to add this package for the dependency injection abstraction. Again, in this project, since we are not actually creating a collection, we just need the abstraction version of the package. Okay, now that we have that, let's add, as usual, our repos folder, and obviously we add a class this class, which is a public class, and as similar to the memory version, is going to be a generic that implements this other generic class, And of course we need to add the reference to the Asta domain core, which is fine. And also, before we implement the interface, we need to remember to add the where clause, which is that tdata must be an Asta document. Okay, now that we have that, we can implement the interface, and let's just reorder the methods so they are in the same order. So we have insert read date, delete, and then the find one, and we are going to implement those one by one. Okay, what else do we need? We need a constructor before we start implementing, and similar to what we have for the in-memory version of the repositories, we have of course we have a dependency here on the Cosmos client that comes from the package that we just installed. And then we have the usual, we have also a database here, because in Cosmos you can have different databases. It's not just containers. Our in-memory version, in fact, is just going to be one container. Actually, it's multiple containers, but we don't pass in the database string. We could change that in the future, to be honest. Okay, let's add all these as fields. And then again, we add a null check to all parameters. And if you remember from last time, we don't need to null check these two, because we will have a default version for those. I'm going to copy in the default. These are actually the same as the in-memory version, so we might do a little bit of refactoring later on to make sure we don't duplicate these default functions. Okay, now we have that, and I think I'm happy with it. Let's see what we need for the insert. So similar to what we have for the in-memory version, we have update fields that is private method that we don't have yet, but I'll copy it in. So update fields, what it does, it just makes sure that your class has the correct doc type, and that if partition key or ID is null, it's going to be populated with the partition generator or the ID generator that we passed in as parameter, or the default ones if we don't have. Again, we can create probably a base class to make sure that we have this in the base class, and also the base class will be responsible for calling this, but we will do that refactoring later, so don't worry about that. And then of course we need to actually use Cosmos DB to make the call. So this is an async task. So from Cosmos, from the client, we get the database, we get the container, and then we create an item, and then if the response is created, which it should be, then we return the resource from the response object. The response object also has interesting things like status code, and it can have the E tag, which is used for concurrency. You can have diagnostic there, but we'll see how we can use some of those later on. For now, I also want to create this exception class that I didn't create yet. So this is going to be a new class here, and it has to be public. Can, and of course this I'm going to create this as generic like that, just so I can store what the resource is, what the response type is. So this exception, let's implement all these constructors, but in our case we will also have to store something else in this exception, just to make sure that we can store some additional data in the case of a Cosmos exception. So this class here comes from Microsoft Azure Cosmos namespace. We add that, and then when we want to throw an exception, we need to pass it in. So we will add it to all our methods here. And then we make sure that we initialize the property for all of these. And that's it for our exception. Now it should work. So when it errors, in this case, because the status is not created, maybe it's something else, we want to still have the response at our disposal. So when an exception of this type is thrown, we still can access things like the status code or maybe something else, and we can check things. At least that's the idea why I created it like that. Let's implement the read. The read is again similar, and it has to be async as well. So we get the database and the container, and that creates for us an object. We use the read item async from there, and if the response is okay, we return the object itself. If it's not found, we replace the exception with our own exception, and in all other cases we just throw a generic one. Let's move on and implement the update. So for the update we have this. Again, it's async. So we use the replace item, which if returns okay, then we have an item, otherwise we don't. And that's it. And we also have the delete to implement. Let's implement that as well. And async again, just because this time we are actually using the await there, so it's fine. Again, we use this method to delete item async based on the partition key and ID. Quite simple and straightforward. Again, if the response is okay, we return the actual item that is retrieved from the data store, and we throw a bunch of exceptions if something else happens. Now the interesting bit is the find one or null. Let's see how that works with the Cosmos instance. So first of all, you will see that we need the async thing, and then you will see that to feed up iterator is not working, and that's because we are using the where condition on IEnumerable here, but what I want to use is another method that is called where, that is on this type return which is an I ordered queryable. So the problem is that where method that is not on IEnumerable, it doesn't accept a function as a parameter. Instead, um, it accepts an expression. So let's change this, and in order to change this we need to fix how it works for the in-memory version as well. So we need to change the actual base implementation of the iRepository that we created. So we'll do that expression which comes from system link expressions. You have to add that using there, and now you see this where condition is the one on iQueryable, which is good. And now if we add the using that we are missing, which is Microsoft Azure Cosmos link, then we have this to feed iterator. Okay, so how this works is that we get the container as usual, and then we run a task to get for a specific partition, we get all the objects that match this condition. And because we are using link, this all should work on Cosmos DB, so it's not like querying the entire partition, getting it in memory, and then filtering on the local PC. It should do the filtering and transform our condition here in a SQL query expression on Cosmos DB, and filter on Cosmos DB itself. Now, once we have the list of objects that match our condition, of course we do read next, and if status code is okay, then we grab the resource from there, which is a list in our case, because the where condition returns a list of objects, not just one. And of course we get the first or default, which means that we get null otherwise. Of course, if the status code is not okay, because this is find one or null, we return null. Okay, now that we changed that, let's change the repository as well. And because we changed that, we need to change the in-memory version. So this is a little bit of refactoring here to make sure that we can have a common interface for all of our data access. And if I can find a method, we can add that. And we add the using statement, and of course now when we call find one, it just expects a function. So in order to have a function, we can have we can compile the expression, and then pass the compiled one. Sorry, I called it F. ABC is a better name because it's condition. Okay, so now that we have that, I want to make sure that everything builds. It should build now. It's taking a while, but it should build. Yes, it does. And I want to quickly run the tests again, just because we changed the in-memory version of the database that we tested before, and I want to make sure that it all still works, and it all still works which is good. Now, of course, similar to the in-memory version, we need Cosmos DB repo factory. Let's add that in as well. And this is repo factory. Alright. And then we need to implement this. This again is quite straightforward, but we need a couple of things here. So of course our factory needs the Cosmos client, which is fine. So we can get our Cosmos client from dependency injection. So we will need as dependency when we use Cosmos DB, we need to register a Cosmos client in there. And another thing that I would like to create is an options class that will store what our database is, because if you remember, this interface that it doesn't have a database string here. So we also want the database to be configurable. So if we want to change the database in the future and point to another database, we should be able to do that. So let's create options there, and we will use what the options pattern from ASP.NET Core, but it's also in .NET 5. So we add these I options of our options class here, and for this we need to also add another NuGet package. So let me grab the NuGet package name, and we can add it fairly quickly. It's Microsoft Extensions Options. So let's add that. So again, it comes with a couple more dependencies, but it's fine. You can have that. And now I'm also missing the using statement that I'm going to add there. So private, let's also add here an options property to store the options that come from dependency injection. So options equal options value. So this means that when we construct the first time this repo factory, it will read the options from the configuration file according to how we configure the options in dependency injection. Let's also add initialize field for this, and we can also have a null check. And we could have a null check for for options as well. Not sure this is going to be any useful, but let's have it anyway. So if options parameter is not there, it will throw an exception, otherwise it will call the value property on it, which will return the actual value of the actual options class instance. Okay, so now the only thing that we still need to do is to actually implement this, and we do that by just constructing a new DB repo, and we pass the Cosmos instance to the repository, we pass the database from the options, we pass the container and all the other properties, all the other arguments like that, and that should be it. We should be able to build this, which is fine. And again, let's add some tests. So as per last time, we add a new project, class library, this, next, next. Sorry, I will mute that. I just sneezed. And if you remember from last time, we need to manage Naked packages and install the test SDK. So we do that. We accept all that. Dependency injection, but not abstraction version. This version here, because we also need to create a services collection to work with. And let me check if we need any other. Yes, of course, before I forget, we need the test adapter. And the test framework package. And now that we have all that, the only thing we need is to create an actual class for the test. So let's add a folder, repos, and we add a class for tests, and it's going to be a public and test. And again, for testing purposes, we will have this test database as a database, and we have a service collection. And again, in the constructor, I will just copy it in so you don't see me type all this. So we need a couple more using statements here. Actually, we need a dependency on Cosmos DB. Of course, we do. And that's that. So this is how we configure the options. So that in our case, the database is our test database instead of being the live one. We need to add a Cosmos client to our dependency injection as well. We can use the Cosmos client builder to this is just a local emulator connection string to the Cosmos DB, so it's localhost 8081, and then you have account key. I think it's this for everyone. It doesn't change no matter how many times you install. But yeah, double check that. I'll show you where to do that. So if you go to localhost, you have your primary connection string here. I just copied this in essentially in there. Because this is a test, it's fine for it to be connecting to the local instance. Probably in the future, when we build the pipeline for testing and we test in Azure pipelines, probably we'll need to change a little bit of this, but for now I think we can go with this and make changes when we need them, rather than trying to anticipate everything, because no matter how hard you try to anticipate everything you need, you won't be able to. So yes, we need a couple more using statements here, one for the models and for the repo. And again, here we just use the abstracted Refactoring to create the actual instance, and because we are using this helper method that I didn't create it, so sorry. Let's go back a second. I forgot to add the configure services class to this implementation, so let's add that, though it's just one line of code. So this is a public static class, just because we have extension methods in here, so it has to be static. And the extension method in our case, we just need the using statement there, and using statement and using statement. Okay, so as you can see, when we use the Cosmos DB repository, the only thing that changes is the factory of the repositories. So that means that here, when we request a repository for this data, it will give us an instance based on the thing on the abstraction that is currently registered in dependency injection, which in our case is the Cosmos DB version. Okay, let's add the actual tests. Similar to the in-memory version, we need a property for creating a new account data. This is pretty much a copy paste of the in-memory test. There is a slight difference in the test that we have this method that we call at the beginning, and that is just to make sure that our database exists, our container exists, so we can add documents to the container. Of course, for the in-memory version we don't need that, because the way we implemented it is that it will just create the container and create the well, the database is just one database, so our memory version is you cannot have multiple databases as it is at the moment. We might change that in the future, and we might want this to also be required for the in-memory version, just to make them the same, but we'll do that in the future, in a future video. If we do that, of course, the benefit is that instead of having these tests that are duplicated, we could have probably just one set of tests with multiple cases, run cases, and having the dependency injection, having two dependency injection service collection, one configured for the Cosmos DB version and one for the in-memory version. But yes, I'm digressing. So let's see how we implemented this. Ensure all the other things are the same. It's just a copy paste of the other one. Nothing much to show you there. So when we ensure the database and container exist, we also make sure that if they already existed, which means that we probably ran the test before and it errored and it never got to delete the container, and also because we want our tests to be isolated, probably it's best to just remove the database and the container every time and then just create them again. When we create a container, obviously the partition key has to be this one. And another interesting thing that I forgot to mention above, when we construct the Cosmos DB instance, is that I changed the serialization options so that our properties are camel cased, which means that if your property starts with an uppercase, it will be converted to a lowercase, and then the rest will stay the same, so that our partition key property in the Asta document matches this partition key partition path key path. Okay, so now that we have all this, I'm not going to explain again what all these tests do. I think you can go back to the previous episode. Maybe I will link it somewhere. Let's see if this all builds, including the tests project. It all builds. Now the hard part is to actually run all this and see if it's actually working. So let's run everything. So technically speaking, the Cosmos DB tests are not unit tests. They are integration tests. So yeah, that's it. Let's see, probably we have some errors. Hopefully not. Of course, because this is actually communicating with Cosmos DB and it's just a local instance, of course it's not going to be as fast as working from data in memory, so it's not going to be just few milliseconds. Especially we have a lot of calls, and we also keep in mind that we delete and recreate database and container every time for each test, and we have a few. So let's see if we can fix this. So as you can see, pretty much everything works except this test. Let's see if we can debug what this is doing. So it's inserting and then deleting, but it's not. So the exception here is exists succeeds, throw an exception. The exception is Cosmos DB item exception, error deleting document. Interesting. Not exactly sure. Not exactly sure. Why is it? Let's go to the implementation here and put a breakpoint and debug. When you don't know why it's erroring, it's not obvious, then you just debug it. So somewhere in here is throwing an exception. So let's see. So delete status code no content. Okay, so that's interesting. I think we will have to compromise here. So I thought that when we use the delete item async, we will get back the document that it's been deleted, but it looks obvious that that's not the case. So we will need to compromise here. Do we actually need the object when we delete something? Probably most of the times we don't. So I would suggest that we actually change the implementation and the abstraction and everything, so that the delete method doesn't have to return any value. Okay, so this is going to be, if status code is no content, then just return, and this is going to be like that, so it's not returning any value, which is fine. Why does it need a generic? Does it need a generic? I'm curious now. No, as I thought, it doesn't even. No, it wants it there, but then it doesn't return the object itself. Maybe there is some options that we can pass to get the data. Let's see. I'm curious now. Okay, I'm not going to play with that because I don't want you guys to look at me trying to figure that out. So we will just go with what I think it's a good thing. I don't think you always need to know what you are deleting, but if you do, you can use the read method first and then the delete one to make sure that you have an instance of what is being deleted. So yeah, let's go to change the base interface here. So delete doesn't have that, and then of course for the in-memory version we need to change that as well, so that when we delete, we just don't return anything. Okay, so that's it. That's fine. Now let's see if everything builds first. Okay, so now when we do all these tests, of course we don't have any data, so it's just going to return that, and in here we don't have any data. So we cannot check any of this. Okay. Again, for the in-memory version as well, we don't have that, and in here we don't have this. So it's just going to be calling the delete, and we expect it not to error. What we do expect though is let's test here that it actually throws an error. So it's fine that it's deleting, but in order for us to check that it's actually deleted from the database, we need let's add a throw exceptions here, check on the read, so that we make sure that if we do read it back because there is a bug in the implementation, we have proper exception. So this is not Cosmos exception, this is in-memory database exception. Okay, let's build again everything and let's test everything. And we wait a little bit for it, but it should all work. Hopefully, unless I miss something very crucial. yes, everything works. So as you can see, it can take quite a while for the Cosmos DB. Even locally, it can take a while for it to run, especially because we delete and recreate it all the time. Um, Probably in the future we will change that so that we only run the Cosmos DB as an integration test during our pipeline and not locally. We'll have a look at that when we get there. Um, yeah, I think for now this is it. Actually, there is one more thing that I would like to add in the core project. So you see we have a static class that contains all the containers that we will use, and of course we have the default one, and probably we won't have anything else for a while here. We also have a list of doc types, and this will update I think very often when we get to a certain point. And another thing that I would like to do is just create a new class of this for the databases. Of course, we only have one, but instead of having just a string in here, um, I would really like this to come from a class where we know what that string is rather than having that string in places. So let's add a new class, databases, and again it's a public static class. We have a public static read only string. How we can call this? Let me let's call it default, similar to how we did for, and by default is Asta database. Okay, so I think at the moment we are not using this, but we could use it to implement the dependency injection later on for the Azure functions. Okay, let's wrap it up here. I think we have a good implementation so far. So we have our domain at the center that doesn't depend on anything really, and then we have our infrastructure for which we created actually two instances, one that is in memory and one is that is Cosmos DB. We will use the Cosmos DB in production and for integration tests, but obviously we can use the in-memory version for unit testing, or what I like to call domain testing, which is like an end-to-end test of the domain. So it's not going to test just one single method, but everything, how it works together. The only difference is that everything is abstracted away and everything is in memory. So the database is in memory, and that's it. Okay, thank you guys for staying with me. I hope you liked this video. If you did, play please leave a thumbs up, and also remember to subscribe so you don't miss future episodes. See you. Bye.